All right, now we're gonna come back to some factoring. It's not like the factoring before, because before it was just three terms. We had something like x squared plus, I don't know, 2x plus 1, and you could split it like this, and we did FOIL. The first term had to make the first one. The last term, 1 times 1, had to make the last one. Then the inners and the outers together had to add up to the middle one. So there was 1 and there was 1. Adds up to 2. Okay, now we're factoring things that have 4 pieces in it. One of the ways to do that, it's called factor by grouping. Okay, factor by grouping is to take this four term thing and split it into 2 groups. So I'm gonna group it like that. I'm gonna take the first 2. Now, you have to be careful if this third one is a minus, because we want this to be an addition problem. So I'm going to make this plus a negative 35, and then group those. You don't want that negative to be part of the grouping, because then that negative is going to eventually get applied to the negative 7 and change it to a positive 7, which it is not. So we're going to give that minus just to the 35 like it was before. Okay, now take a look at these two. We want to factor out the most we can out of those two. So I can see they both can have a 5 and they both have an a squared. So I'm going to divide out a 5a squared. If I do that, 25 divided by 5 leaves 5, and I took out a squared, so that leaves an a. And this 5a squared divided by 5a squared leaves a 1. Remember, factoring is a division kind of problem. So we took this 5a squared divided by 5a squared, left a 1. Okay, over here I see I can factor out a negative 7. So I'm going to factor out a negative 7. Negative 35 divided by negative 7 is 5, and then there's still the a. And negative 7 divided by negative 7 is positive 1. Now, factor by grouping works if these two things are always the same, because now we're going to factor that again. And sometimes kids can't see what's happening here. So this will help. I'm going to circle this and make it a Q. So it really looks like 5a squared Q. Now I can call this minus 7Q or plus negative 7Q. It doesn't matter now. So minus 7Q. You notice that these both have a Q in it, so I'm going to divide that Q out. If I divide the Q out of this piece, there's a 5a squared left, and if I divide the Q out of that piece, there's a minus 7. Okay, so sometimes that helps kids to see that, okay, there is a common thing that can be divided out one time. Now just put the Q back. Q was just made up, so Q was really 5a plus 1. And then, so that's the Q part, and now this part was left as 5a squared minus 7. And we have that 4-term polynomial split into the 2 things that multiplied together to make it. Okay, let's try that again. Okay, there's no subtraction to worry about there, so I'm just going to group those 2 with those 2. So now I have it in 2 groups. And when I look at the first group, I see again I can divide out a 5 and a p squared. So I'm going to divide out a 5p squared out of the first group. 40 divided by 5 is 8, and I took out 2 p's, so there's 1 left. And 25 divided by 5 is 5, and we took out both of the p's. So there the first piece is factored. Plus, now when I take a look at this one, it looks like it can divide out a 4. 32 divided by 4 is 8p, and 20 divided by 4 is 5. And sure enough, this term right there is the same. So I can replace it with a q. So really I have 5p squared q plus 4q. And now this q can come out. Now, q is nothing special. I'm just making up a letter. You can call it your favorite letter, but Q is easy. I circle it and put a little thing there so it looks like a Q. So now they both have a Q in it, which I can factor out. So if I take this piece and divide out the Q, there's a 5p squared left. If I take this piece and divide out the Q, there's a 4 left. So now rewrite it. Q is just something made up. So Q was really 8p plus 5, and then the other piece is 5p squared plus 4. And we have that one factored. Okay, one more. Okay, right here, I'm going to group those two together, but now I don't want to group this with that minus there, so I want the minus to be specifically only on the 4. Okay, it looks like you can divide out a 6r squared here on the first grouping. We can pull out a 6r squared. Okay, so 24 divided by 6 leaves 4r, and 6r squared divided by 6r squared leaves a 1. Here, I want to divide out, so I want these two things to match up. I need it to be a 4r plus 1, and right now it's negative 4r minus 1, so I'm going to factor out a negative 1. So negative 4r divided by negative 1 leaves 4r, and negative 1 divided by negative 1 makes it plus 1. And see, we got these two things to be the same, which is what we need in order to factor it again. It's like a double factor. So we have 6r squared q plus negative 1q. Okay, I can divide that q out. If I divide the q out of this piece, we have 6r squared left. If I divide the q out of this piece, I have a minus 1, and rewrite it without the q. Q was really this 4r plus 1, so I had the factor 4r plus 1 times whatever was left, which was 6r squared minus 1. And there we have a 4-term polynomial factored by grouping. Okay, so that's one new kind of factoring. When you have a 4-term thing, how do you get that factored? Well, you split it into 2's and 2's and see if you can't get it factored by grouping. The next thing that we want to do, if you take a look at number 8 or number 6 down there, it has a cube in it. Okay, so that's called factoring perfect cubes. Okay, here's what a perfect cube is. 1 is a perfect cube because it comes from 1 to the 3rd is 1. Let me go the other way. 1 to the 3rd is 1. 8 is the next perfect cube because that comes from 2 cubed. 2 times 2 times 2. So 3 times 3 times 3, the next perfect cube is 27. 4 to the 3rd, 4 times 4 times 4 is 64. 64 is the next perfect cube. 5 cubed, 5 times 5 times 5 is 125. 6 cubed is 216. That's the next, I'll go up to maybe 10 or so. 7 cubed is 343. 8 cubed, see these are pretty big numbers now. 512. 9 cubed is 729. And 10 cubed is 1,000. So there's the first 10 perfect cubes. When you're factoring perfect cubes, we are really looking for these. We're looking for these numbers. We need to be able to pay attention to if we have one of those. Here's what perfect cubes look like. Let's pick one of these. How about I pick the number 125? Okay, so the problems look like this. X to the 3rd minus 125. That's called a perfect cube kind of problem because that's a perfect cube and that's a perfect cube. When I say perfect cubed, I mean we can rewrite it like this. It's the variable x by itself all to the 3rd, and it's the number 5 by itself all to the 3rd. See, it's something to the 3rd minus something to the 3rd. Okay, we need a formula for that. Here are the formulas that you need to remember to factor perfect cubes. If you have a first number to the 3rd plus a second number to the 3rd, that's what a perfect cube looks like. It factors out like this. A plus B is the first one. And then A squared, let's see, is it two of them or one of them? Oh, I better check to make sure I don't get this right. Yes, just one. A squared minus AB plus B squared. What I want you to notice is if this is a plus right there, that is also a plus. So the first two are the same sign. And then the next one is different. And then this one is always positive. Now you'll see why I'm making that distinction, because there's one more. So that's called a perfect cube for addition. Well, this problem is perfect cube for subtraction. So it's a to the third minus b to the third. Now this a and b can be any number as long as they're perfect cubes. Okay, that factors to a minus b times a squared plus ab plus b squared. Now you see how the first two are the same. The next one is different. And this one is always positive. Okay, those are the notes for perfect cubes. So what you do for the problem is, once you identify it as a perfect cube, see now the x is like the a number and the 5 is the b number. So we come over here and follow this one. It's the a number minus the b number. So this is going to factor to the a number minus the b number. So that's the x minus the 5. Then the formula says the a value squared. So it's the first one squared. So it'll be x squared. Then there's a plus. And then it's the a number times the b number. So it's the 5 times the x. And then there's a plus, and then the b number squared. So 5 squared is 25, and there that thing is factored. That's how we're going to use those. Okay, so let's take a look at some examples and see how to build it. So we have to recognize that 8 is a perfect cube and rewrite it as its cube. So this really means x by itself to the third minus 2 by itself to the third. Okay, see, that's the a number and that's the b number. The x is the a position and the 2 is the b position. Now just go plug it in the formula. It's the a position minus the b position, so it's the a minus b, so that'll be x minus 2. Then the formula says a squared, so it's this piece squared. Then there's a plus, and then it's the a piece times the b piece. So the b is not negative 2, the b is 2, so it's this middle term is positive, so it's 2 times x. And then plus the b number squared, so 2 squared is 4, and there it's factored. Now this second piece down here almost never factors further. We might try to check it as FOIL, x times x, but the only thing that could make a 4 is a 2 times 2, but see the inner outers don't add up to 2. Or we could try 4 and 1, but the inner outers don't add up to 2 again. So that second bigger piece does not factor any further. Okay, when I look at this one, 375, that is not on my perfect squares list, and neither is the 24. So something must factor out of that. Let me see. Let me see if 3 does. I know 3 plus 7 is 10 plus 5. Those digits add up to 15, and since 15 is divisible by 3, I know I can divide a 3 out of that, and I can divide a 3 out of that. But dividing that by 3 still doesn't make 24. Yeah, it does. 24 divided by 3 is an 8, which is a perfect cube. So let's take a 3 out of this and see what happens. Okay, 375 divided by 3 is 125 x to the third, and 24 divided by 3 is 8. Okay, 125 is a perfect cube, and 8 is a perfect cube. So this can be factored as a perfect cube. So I'm going to rewrite it first. It's 3. Okay, 125 x to the third is really 5x all cubed. See, that's the a part. The 5x now is the a part, minus a 2 to the third. The 2 is the b part. And now we just go follow our formula. So this 3 is part of it, so I got a 3. But then for subtraction, it's right here. For subtraction, it's the a piece minus the b pieces. So it's 5x minus 2. Then it's the a piece squared. So 5x squared is 25x squared plus a times b, so it's going to be 2 times 5x, so that's 10x, plus the b value squared, so 2 squared is 4, and there we have it factored. Okay, look at number 8. That's a perfect square, and that's a perfect square. I can rewrite that as 5x by itself cubed minus 2 by itself cubed. Okay, so that's the a value and that's the b value, and plug it in the formula. So these are easy as long as you can remember the formula and identify perfect cubes. Once you do that, you just plug it in. So it's a minus b, then we need a squared, so that'll be 25x squared. Then we need a times b, opposite sign, so it'll be plus a times b is 10x, plus the b number squared is 4. Here, 2 is not a perfect cube, neither is 250, but I can factor the 2 out. 2 divided by 2 is 1. 250 divided by 2 is 125, u to the third. Now, 1 is a perfect cube, and 125 is a perfect cube. So let's split it up. So it's really 1 by itself cubed, and 5u by itself cubed. I'm just rewriting it so that they can look like perfect cubes. So now 1 is the a value, and 5u is the b value. And go plug it in the formula. So I've got the 2. The formula says a plus b, so 1 plus 5u. Then it says a squared, so 1 squared is 1. The signs are different, so it'll be minus, and then it says a times b, so 1 times 5u is 5u, and then it's plus the last term squared. 5u squared is 25u squared. And there we have it, factored. Okay, now on the back we have a triple. Okay, so triples should do FOIL. We should be able to split that up something like this, but this one doesn't start out with a square, it starts out with a 4. That's okay, you can still do that as long as these are cut in half each time, like 4, cut in half 2, and then the last one is 0. 4, 2, 0. 6, and then half the term is 3, so these will work with FOIL. To make it start out, let's see, you can certainly divide out a 5. What's 215 divided by 5? 43. First I'm going to take out a 5 just to make it easier. That's going to leave 10x to the fourth, 43x to the second, and 140 divided by 5 is 28. Okay, I don't particularly like this one. Looks like it's going to have lots of choices. Let's see what we have going on here. So, of course, I have the 5 in front of that. So 10s, I have my choices are 1 and 10, 2 and 5. For 28, we have 1 and 28, 2 and 14, 3 and 8. No, that's not right. 3 doesn't go into 28. 4 and 7. So that has to somehow add up to 43. Well, let me just test a few. How about 2x and 5x? Maybe we'll go, got to get it up to 43. So how about we try 14 and, well, 56. How about 14 and 2? I don't know if that's good enough. That's 28 and that's 10. That's not going to do it. If I switch it around, that's not going to be enough either. So how, or will it? What if I put the 14 there and the 2 there? 5 times 14 is 70. 2 times 2 is 4. Yeah, so that's not going to do it. How about we try 7 and 4? 2 times 7 is 28. 4 times 5 is 20. 20 and 28, not quite 43. If I go the other way, 7 and 4. This makes 35. 2 times 4 is 8. 35 and, okay, 35 and 8 will make it. So I have a 4 there and a 7 there, right? So 7 times 5 is 35. 2 times 4 is 8. 35 plus 8 is 43. They both have to be added. Okay, so there I got it factored. Now, for FOIL, for first, 2x times 5x is only 10x squared, so I need 2x squared and 5x squared. Now it's 10x to the 4th, and now when I put these x's on there, so I've got 5, 2x squared plus 7, and 5x squared plus 4. See how the middle term right there is 35x squared, and then the outer terms are 8x squared, which adds up to 43x squared. Okay, so FOIL. I just need an x squared term there, so 20. 1 and 20, my choices, 1 and 20, 2 and 10, 4 and 5. For 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. So I have lots of choices again. Let's see. Well, I don't know. How about we start with the middle one? I'll start with 4x squared and 5x squared. And got to try to get it to 1, so I'll try to keep something reasonably close here. What if I put a 5 and a 6 there? That's 25 and that's 24. That will probably do it. There's 25x squared. There's 24x squared. I need it to be a positive 1, so that needs to be positive, that needs to be negative. So the outers have to be negative, the inners have to be positive, and positive 5 and negative 6 still make negative 30. So there we have it. 4x squared plus 5 and 5x squared minus 6. So 6, 3, and 7 should be the same thing. We just need an x to the third. So 8 is 1 and 8, 2 and 4. 7 is just 1 and 7. Okay, and I need the middle to be a 5. How about we start out with 2x to the third this time? And maybe go 1 and 7. Can I get that to be 5? There's 4, and there's 14. So that's never going to get to 5, so let's go the other way. Now the outers, 2 times 5 is 10. The inners, 4 times 7 is 28, so that's not going to do it. So it's not the 2 and the 4. So we'll try 1 and 8. Okay. Now, what do I have here? 1x to the third, 8x to the third with 1 and 7. Okay, there's 7, there's 8. 7 and 8 are never going to make 5. So let's make that 7 and that 1. So now I've got 56 and 1. That's never going to make 5. So this one's not factorable, not because of the 6, but because the combinations of 8 and 7 can never go to a 5. Okay, 13. We can do this one too. It's just going to start out with something to the 4th. So let's see, can I take out a 4 to 70 divided by 4? No, can't take out a 4. Can I, does 70 divide by 6? No, so it looks like it can only divide out a 2. That leaves 12x to the 8th minus 35x to the 4th plus, what, 18? So now I got to work on 12s and 18s. So 12s are 1 and 12, 2 and 6, 3 and 4. 18 is 1 and 18, 2 and 9, 3 and 6. Oh, let's see. We got to get a pretty big number in there. So maybe I'll start in the middles. 3x to the 4th and 4x to the 4th. That makes 12x to the 8th. I'll try that one maybe with the 3 and the 6. So there's 12 and there's 18. 18, 28, 29. So that cannot make 35. So let's try it the other way around. 6 and 3. Now there's 24 and there's 9. Close. 24 and 9 makes 33, but not 35. So if I have 3 and 4, it won't be that one. How about 2 and 9? 3 times 9 is 27. Okay, that one might work. That's 27. 2 times 4 is 8. If I add those together, if I make them both negative, I've got negative 35. So if I make this one negative and that one negative, a negative times a negative is still a positive. So I think we found it. So I've got a 2, got a 3x to the 4th minus 2, and a 4x to the 4th minus 9. Okay, one more. I personally don't like having a negative in the front. I like to divide out the negative and just make it 12m to the 8th and then plus 13m to the 4th and then minus 90. That feels easier to me. All right, 90 is not going to be a fun number to deal with. Sure would be nice if we could factor something out and make it smaller, but it's not. So I have 1 and 12, 2 and 6, 3 and 4 over here, but 90 has a lot of factors. Okay, 1 and 90, 2 and 45, 3 and 30, 4 doesn't go in there, but 5 does. 90 divided by 5 is 18, so 5 and 18, 6 and 15, 7, 8, 9, and 10. Okay, so there's all the choices for 90. I don't think I'll start out with 12. How about we start out with 2 and 6. 2m to the 4th and 6m to the 4th, and see if we can't get something to go there. 13. Oh, I don't know. I don't want 2. I think I'm actually going to start out with 3 and 4. 2 and 6 doesn't feel like it's going to go anywhere. How about 3 and 4 and maybe 6 and 15? That's 24. 3 and 15 is 45. 45 minus 24 is 21. So that's not it. What if I put the 15 here and the 6 over here? So here I have 15 times 4 is 60, and 3 times 6 is 18. 60 and 18 are not going there, so that one's not going to work with the 3 and the 4. What do I have here again? I have 3 and 4. Maybe I'll try the 5 and the 18. Three times 18 is 54. That's 20. That's not going to be 13. So I'll go 18 here and 5 here. 18 times 4 is 72. That's not going to make it either. Okay, that's not going to work. So maybe the 3 and the 4 is no good. I haven't tried them all. Probably should try a couple more. 2, maybe I'll go with 2 and 6. So I'm still trying to get to 13. So how about I go 18 and 5 there? Okay. Here's 30. There's 36, so that's not going to do it. If I switch them around, 18 like that and 5 like that, 18 times 6 gets too big right off the bat, so that's not going to be it. So the 18 and 5, I'll try, before we move on, I'll try the 6 and 15. Now the outers are 30. 6 times 6 is 36. That one's not going to do it. Maybe I'll try the 3 and 30. That's 60 and 18. That's not going to do it. How about the 9 and the 10? There's 54 and 20. Okay, let's see. It's possible this one is not factorable. I'm going to come back to that one in just a second because right now I'm thinking it's not factorable and I don't want to waste anybody's time. Just keep looking through all of the possibilities. So let's do 15 and call it good. Okay, first one I'm going to factor out the 2. 32 divided by 2 is 16, m to the 8th minus 1. Okay, so first of all, I want to check and see if 16 is a perfect cube. So as we can see over on our perfect cube, it is not. But it is a perfect square. So a perfect square means it can split up into the square root of 16 is 4, and the square root of m to the 4 is, m to the 8 is 4. So 4m4 times 4m4 is 16m8. And the square root of 1 is 1, and the square root of 1 is 1, with one of them a positive and one of them negative. See, that makes a middle term of 0, which it has up there. Okay, there's a whole bunch of different factoring techniques.